It's in your book too. Okay, if you look at your spinal cord and your brain are flipped. If you look at your brain, the surface of your brain is like this. Okay, if you are fans of Hercule Poirot, the famous crime-solving Agatha Christie guy, he always talks about he's got to get his little gray cells working. That means he's thinking. This, on the outside of your brain, is the gray matter. The inside is white matter. Okay, the gray matter is thinking, processing. The white matter is tracks. This is transportation. So this does the thinking. This sends a signal somewhere else. Okay? The white matter is myelinated tracks. So they're going a long way. The gray matter is not myelinated. Myelin is white. The gray matter is short communication, and it's processing and thinking. Okay? It's on the outside of your brain. The more convolutions you have on your brain, what's that doing? That's increasing the gray matter because it increases the surface area. So if you look at a cat's brain, instead of being like this, is more like this. Where you dive way down. So you have all of this surface and that surface where the cat doesn't. You're smarter than, most of you are smarter than a cat. Okay? More gray matter, more thinking and processing. The tract area is almost the same in the two of you. Not much difference. In your spinal cord, this is gray. It's flipped. It's now on the inside. The outside is white. So this is thinking and processing. This is signal transmission. And you notice you've got two spinal nerves coming out here and two spinal nerves coming out here, out of the spinal cord. But you've only got one coming out of the bone. And this is your spinal nerve. And it is mixed. That means it's got motor and sensory. However, they split once they get inside the vertebra. This is sensory. This is motor. Okay? Your sensory information comes in from the outside. Here it comes. And it has a cell body right there. Then the axon comes into here. So this is dendrite, cell body, axon. Get it out. Okay, when you send a signal in, that's what happens. This swelled area here is called the dorsal root ganglia. This is dorsal, your back. Okay? The body of your vertebra is here. The arch is coming, actually the body's even bigger than this, it'd be like this. The arch is coming up like this. Like that. Okay? This dorsal root ganglia is therefore, it is dorsal. It's on the dorsal root of the nerve. This is dorsal. It is a ganglia. A ganglia is a collection of cell bodies of the peripheral nervous system. Okay, so a ganglia collection of cell bodies in the peripheral nervous system. Now, what is the peripheral nervous system? Everything but the spinal cord and the brain. Some books will also include the retina because it is an embryological extension of the brain. But for you, brain and spinal cord. Okay, ganglia is a collection of cell bodies in the peripheral nervous system. See, this is not yet in the spinal cord, is it? It hasn't entered, so it's still in the peripheral nervous system. Okay? It's going to synapse with an interneuron. That means it is within the gray matter. It is doing what? Thinking and processing. Okay? If it is a reflex arc, this would be its dendrite. This would be its axon. If it's going to be a reflex arc, it's going to go into the spinal cord. It's going to come right back out as a motor neuron. Here's your motor neuron. So what is this? Dendrite. Cell body. Here's your axon. Okay? A cluster of cell bodies inside the central nervous system is going to be called a nucleus. So if I change this to nucleus and change this to CNS, I've got a nucleus. So this would, if there are a bunch of them, this would be a nucleus, this would be a nucleus. A cluster of cell bodies in the central nervous system is a nucleus. A cluster of cell bodies in the peripheral nervous system is a ganglion. Okay? Now you notice, right, we had, if we're going to send the information up to the brain, we send it in with the sensory. We talk to this interneuron, and this interneuron will come out here into the white tracts.